Welcome to today's lecture. Today's topic is again tenderization and it is part 2 of this. In the previous lecture, I have covered in the part 1 about the more common and traditional methods of tenderization of meat, including conditioning or aging, and then tender stretch, tender cut methods, then marination or cooking methods, and about the mechanical methods of tenderization. Of all those, the mechanical methods, there is involvement of modern scientific machineries for tenderizing the meat. Today we will talk about the more advanced and more modern methods of tenderization, like about the electrical stimulation, the enzymatic method, the calcium chloride infusion, and high pressure method for tenderization. As I mentioned, today we are going to discuss these four modern methods of tenderization of meat. The first one is electrical stimulation. So this is a quite modern method, but it is commercially in use already. So here the electrical stimulation helps in quick onset of rigor mortis, and then we can go for early chilling without the effect of cold shortening, and it also helps in breaking the muscle structure or sarcomere structure and helps in tenderization. The second one is the enzymatic tenderization, where both plant origin and other bacterial fungal enzymes are also used. They are proteolytic enzymes, causes breakdown of the proteins at different stages, either in the connective tissue or in the myofibrillar or Z-line proteins. And the third method is infusion of calcium chloride. So this is a modern method. Lot of research has been done, and in calcium chloride helps in activating the inherent internal enzymes and helps in tenderization. And the fourth is high pressure tenderization. This is again a very modern research development. Due to the very high pressure, it causes degradation of cytoskeletal protein or muscle structure and helping in tenderization of meat. So all these four I am going to discuss today in details. So the first method is electrical stimulation. Electrical stimulation of carcass following slaughter is the new commercial method of meat tenderization, as I have already mentioned. Here the electrical stimulation was first introduced in New Zealand in an attempt to avoid the cold shortening of muscle resulting from rapid cooling or chilling of lamb carcasses. This we have discussed earlier in many lectures, that normally we are recommending that the carcasses should be chilled at the earliest. But if we chill the carcass before the rigor mortis is over, it leads to shortening and the meat become tough. So to resolve this issue, they developed a new concept, that is to apply the electrical stimulation, which causes early setting of rigor mortis, or the rigor mortis comes very early, then we can go for early chilling. So now it is widely practiced in meat industry world over, and electrical stimulation is the application of sufficient current into the carcass during slaughter process. So this process came into practice only to avoid the cold shortening due to early chilling, but later it has been further developed for making the tenderization, which we are going to discuss step by step. In continuation about electrical stimulation, here pulses of electricity are passed through the carcass immediately after slaughter, and the current causing the muscles to contract vigorously, and thereby use of glycogen, ATP and creatine phosphate. So the electrical stimulation causes vigorous contraction, use of the glycogen and ATP, and then the rigor mortis sets early. So it is done before rigor or in pre-rigor carcass. The electrical stimulation of pre-rigor muscle causes the carcass to undergo rapid series of muscle contraction and relaxation, and thereby use all the glycogen energy or ATP, and then rigor mortis sets early. So the rapid series of contractions and relaxations of muscle accelerates the rigor. Now such carcass can go for early chilling, but this vigorous contraction also causes degradation of myofibrillar or cytoskeletal protein and helps in tenderization, which we will see later. Now we will see the ideal time of electrical stimulation. The electrical stimulation can be performed at any stage. However, it is better to do within 30 minutes of bleeding. So immediately after the dressing. So this 30 minutes time will take for finishing the dressing. So it should be done immediately after the dressing operation is over. Otherwise, the muscles will lose their capacity to react to the electrical stimulation, because the electrical conductivity should be better, and that is possible at the early stage. So as the length of time between bleeding and stimulation is increased, the electrical stimulation becomes less effective. So the duration from bleeding to electrical stimulation, if it increases, the effect of electrical stimulation will be less. Since the post-mortem resistance develops and muscles of these carcasses can be shortened and tough. So if we delay the electrical stimulation, the post-mortem resistance will develop, muscle will start shortening, and it will become tough. So it should be done at the earliest. Now you will see the animals suitable for electrical stimulation. Actually, electrical stimulation is more applied to carcasses from sheep, goat and cattle than pig, because the cold shortening is less of a potential problem with pork carcasses, because in pork carcass the development of rigor mortis is quicker. So the rigor mortis comes quicker in case of pig, so it is less commonly practiced in case of pig, because the cold shortening problem is comparatively less. However, with very fast chilling procedures, electrical stimulation may be beneficial. So when we want to do very quick chilling, in that case electrical stimulation should be practiced even in case of pork. Now we will see the advantages of electrical stimulation. So electrical stimulation improves the quality of meat from aged or spent animals, because meat of aged or spent animal will be very tough. So this electrical stimulation helps increasing the tenderness and also reduces the aging times, because of the vigorous muscle contraction very high level. So it causes fragmentation or degradation at the cytoskeletal protein or jet line or gap filament, and thereby it reduces the chances of toughening due to rigor mortis. It improves appearance and color of lean. It can advance the process of rigor mortis as we have told earlier, and also it helps in avoiding the cold shortening and thaw rigor. Because of the early chilling there is a cold shortening, or if it is frozen before rigor mortis is over, so that leads to thaw rigor. All these problems are avoided by applying the electrical stimulation. Here we will see the mode of application of electrical stimulation. The current can be applied through various combination of electrodes, but usually it is done between muzzle or nose, the chest and hind legs of animals. But this is before dressing or flaying of the carcass, but it can also be done after dressing, where the electrodes can be applied at neck region of the carcass and at the hind part of the carcass or thigh region. Usually the current is applied as a series of pulses of 1 to 2 second duration and for a period of up to 90 seconds. So a series of pulses are applied of a duration of 1 to 2 seconds up to 90 seconds. This is applied. Here we can see the diagram for electrical stimulation. We can see there are two electrodes, one at the hind leg region or thigh muscle and one at the chest region. In the left side diagram we can see the actual carcass, where the one electrode is at the leg region and one at the neck region. Now there are different methods of electrical stimulation. So it can be high voltage stimulation and low voltage stimulation. In the high voltage it is more than 500 volts and it can be up to 1000 volts, and there is low voltage which is up to 75 or 100 volts, that is at a lower range. Now we will discuss some details about high voltage stimulation. High voltage stimulation systems are more expensive than low voltage stimulation and have complex safety mechanism to prevent accidental electrocution of workers. So this is more expensive and this is more risky, so it needs special safety mechanism, so that's why it is more costly. In this system, the muscle gets direct stimulation due to flow of current and generally does not depend on animal's nervous system. So here the voltage is very high, so there is a direct flow of current, so it is not necessary to have the support of nervous system. High voltage is effective in accelerating post-mortem glycolysis for 1.5 to 2 minutes. So because it is a very high voltage, the glycolysis can happen in 1.5 to 2 minutes. And this system can be applied much later of bleeding. So here the normal nervous system mechanism is not required, so it can be done later of bleeding, not necessary to do immediately after the bleeding, as I have discussed earlier. Now we will talk about low voltage stimulation. Here the muscle gets stimulation through nervous system. So the voltage is low, so it is spread through the nervous system. Hence the low voltage system are usually applied immediately after bleeding. That we have discussed earlier. It should be done at the earliest maximum within 30 minutes from bleeding. It is a cheaper system where complex safety equipment is not required because the voltage is low, around 75 to 100 volt, so it does not need much safety arrangement, so the equipment is cheaper, but it is considerably slow process. Because it is a low voltage, it is a slow process, whereas in case of high voltage it is very effective and very quick. Here is a comparison between low voltage electrical stimulation and high voltage electrical stimulation. The parameters are in the left side, that is the voltage used. In case of low voltage it is 100 and below, whereas high voltage it is 500 to 1000. The current, total current used is less than 1 ampere in case of low voltage, whereas in high voltage it is more than 5 amperes. Duration of current applied, here it is up to 20 seconds, whereas in low voltage it is up to 90 seconds. The time of application, low voltage it should be applied immediately after bleeding or within 5 minutes of stunning. So here we cannot go up to the dressing and then wait for that. Immediately after bleeding we have to apply it, whereas in case of high voltage it can be done up to 60 minutes post-mortem. So it can be done after the dressing operation is over, directly on the carcass. The mode of action, in case of low voltage it stimulates the muscle through the nervous system. Because it is within 5 minutes, the nervous system will be still responsive, so it uses that advantage, whereas in case of high voltage it is done much later. Because of the high voltage, directly it stimulates the muscle. Here we will see the effect of electrical stimulation on muscle or meat and how it works. So due to the extensive muscle contraction, in the left side we can see in the diagram, due to extensive muscle contraction there is accelerated loss of high energy phosphate or ATP and creatine phosphate, and that leads to rapid onset of rigor mortis, and which minimizes the cold shortening, and also it prevents the dark or coarse band formation. Simultaneously, in the right side we can see accelerated glycolysis happens due to the electrical stimulation, due to vigorous contraction, that leads to rapid pH decline and slight buildup of heat. Now this rapid pH decline leads to liberation of calcium activated sarcoplasmic factors or calcium dependent proteases. That happens due to rapid loss of energy phosphates and rapid pH decline, and all this causes enhanced proteolysis, that is the leading to aging effect or tenderization. And sometime due to rapid fall in pH and buildup of heat, it causes some denaturation of protein, and that causes accelerated decrease in water holding capacity and protein solubility. So these are the effect of electrical stimulation on muscle or meat. Here we will see in brief the effect of electrical stimulation on meat qualities or meat properties. So it is a brief summary of the overall effect of electrical stimulation. The tenderness is improved, the color of lean improved, quality grade improved, marbling more visible, flavor enhanced, heat ring prevented, that is due to the slow cooling of the carcass. The aging period is shortened. The case life of meat, that is the shelf life of meat, is extended. The ATP depletion is highly accelerated. Onset of rigor mortis highly accelerated, and hot boning and hot processing. This is a modern practice for deboning of the carcass immediately after slaughter. So this is allowed due to early rigor mortis. We can easily practice the hot burning or hot processing. So these are the advantages briefly in short due to electrical stimulation. Now the second method, enzymatic tenderization. We are going to discuss about the tenderization by enzymes. So tough meat can be made tender by use of several proteolytic enzymes obtained from plants, bacteria and fungi. So these proteolytic enzymes can break down the proteins either at the myofibrillar level or at the connective tissue. These enzymes, as I said, broadly in two categories. One is plant origin, where we can see commonly used enzymes like papain from papaya, phycin from figs, and bromelain from pineapple. These are commonly used. And the bacterial and fungal origin enzymes like protease 15, rozyme, fungal amylase, hydrolase, even sometime actinidine, that is an enzyme from fungal origin. So these tenderizers can be used in liquid or powder form, applied over the meat and given some time, and they become more effective when it is cooking at a little bit higher temperature. Their activity is more. So here in our discussion, the plant origin enzymes only we are going to focus more, and some of the commonly used enzymes from plant origin for the meat tenderization, as I mentioned already, that is the papain extracted from papaya. The papain is also available commercially in powder form. Then bromelain extracted from pineapple. This is also available for common use. And phycin extracted from figs. So this is also commonly used. These three enzymes of plant origin are very effective in the tenderization of meat. The enzymatic tenderization, of course, we are going to discuss more details how they are applied. So generally the primal cuts of meat like rib or loin is injected with these enzymes in the solution of enzyme, and after that the steaks are cut from the primal cuts and cooked. So first the bigger cuts, primal cuts, are injected with different enzyme as a solution. Then after some time when they are cut into steaks and then go for cooking. But the more effect will be when it is heating during cooking. So about the action of these enzymes, the bacterial and fungal proteolytic enzymes act only on the proteins of muscle fiber, causing digestion of sarcolemma, degradation of muscle fiber, and eventually loss of cross striations. So the enzyme from bacterial and fungal origin are more active on the proteins of muscle fiber. The main features of these enzymes are that they attack native collagen as it is denatured by heat during cooking. The enzymes of plant origin, they specifically attack more on the collagen and causes denaturation due to the heating, and after that these enzymes do the degradation. They break down the heat denatured connective tissue proteins to soluble hydroxyproline containing molecules. So these plant origin enzymes causes breakdown of connective tissue and produces hydroxyproline molecules. Now about the action of enzymes. the heat of cooking activate these proteolytic compounds to help tenderize during the cooking process. So most of these plant origin enzymes are cysteine enzymes. So they are activated during the heating of cooking, and thereby they cause the breakdown of the proteins in the muscle and causes tenderization. So these enzymes are activated by heat at 37 degrees Celsius and deactivated at 60 degrees Celsius and above. So there are tenderizers that can be purchased for home use as well. These proteolytic enzymes of plant origin preferentially act against connective tissue protein. So other enzymes which is not from plant origin, that is bacterial or fungal origin, they act more on the myofibrillar protein, as I told in the beginning, whereas the proteolytic enzymes from plant origin act mainly on the connective tissue protein, that is on the collagen fibers. Now we will discuss about the methods of application of these tenderizing enzymes. So there are several approaches. The one of the approach is dipping of meat in enzyme solution. So we can prepare a solution of enzyme and dip the meat over that. Secondly, introduction of enzyme solution into the meat pieces through fork holes before cooking. So when meat pieces are relatively bigger in size, we can do the piercing with the fork, and through that holes the enzyme solution can be added. Then there is third option, pumping the major blood vessels of meat cuts post-mortem with enzyme containing solution. So we can make the solution of enzyme and we can pump it through the major blood vessels of the meat cuts. So as we discussed earlier, there are bigger primal cuts. There will be important blood vessels, say femoral artery. So in that we can inject the solution and it will reach the entire muscles. Then the fourth option is rehydrating freeze dried steaks in a solution containing proteolytic enzymes. So we have discussed earlier in the preservation there are freeze dried meat which should be rehydrated before use. So for that rehydration we can prepare the proteolytic enzyme solution and then that solution is used for rehydrating. In continuation about methods of application of enzymes, so here is another option, that is pre-slaughter injection, maybe 10 to 15 minutes before slaughter of the solution. The solution can be 5 to 10% concentration and the dose is 0.5 milligram per pound, or it is about 1.0 milligram for a kg. So this is the one option, that is before slaughter we can inject the enzyme solution. Now after the injection the animal should be slaughtered within 10 to 15 minutes. The optimum time range for maximum tenderness, that is 10 to 15 minutes before slaughter we have to inject the enzyme solution. Now this enzyme solution will be distributed everywhere in the muscle. Now after dressing, then when cut into pieces, then this meat when it goes for cooking, that time the enzymes get activated at around 60 degrees Celsius and it causes tenderization of meat. Now specially we want to discuss about a new development about the plant origin enzyme as tenderizer, that is the ginger extract. As we all know, ginger is widely used in household or in restaurant for marination or cooking of meat because of its spicy flavor. So particularly in Indian household, ginger is most common for cooking of any non-vegetarian food, particularly mutton, beef or pork or chicken, and it gives a special flavor. Now recently ginger rhizome was investigated as a new source of proteolytic enzyme of plant origin. So there are few new research in last 1 or 2 decades which proves that the ginger rhizome has got excellent tenderizing enzyme. So this proteolytic enzyme isolated from ginger rhizome is known as gingiben, and this gingiben has got excellent properties for tenderizing of meat. Now about the tenderization by ginger extract, few more details. The proteolytic activity of this enzyme was found to be many times greater on collagen than on actomyosin, thereby considered to be effective for tenderizing meat from old animals. So these ginger origin enzymes, even most of the plant origin enzymes, are more active against the collagen, that is the connective tissue protein, and which gives the background toughness, especially in old animals or spent animals, whereas it is less effective in actomyosin or myofibrillar protein. The ginger extract also possesses antioxidant and antimicrobial properties. So this has an additional advantage on the shelf life or storage life, and it is more suitable for facilities serving the pre-cooked meat. So many facilities which is serving the small restaurants pre-cooked meat, their application of ginger is also useful for preservation or increasing the shelf life and also for tenderization. So this ginger extract has been shown to be very effective in improving the tenderness and other sensory characteristics of spent hen meat or other mutton or meat from old animals. Here is another new plant origin enzyme from the plant Cucumis trigonus. The fruit from this plant, there are a lot of work found to have tenderizing effect. So this Cucumis is a wild plant found in India, and the dried fruits of this plant are used traditionally during cooking of meat to improve taste. But recently some of our scientists, especially in IVRI, has done some research work using this fruit and found that it is very good for tenderization of meat. It has been observed that protease named curcumin obtained from fruit of Cucumis trigonus has got very good proteolytic activity, and that helps in the tenderization of meat. So in continuation, some more details about the activity of Cucumis trigonus. The crude extract of dried Cucumis fruit was found to improve tenderness and overall palatability of pork and buffalo meat. So firstly, it was found that extract of dried Cucumis fruit was very effective in pork and buffalo meat as tenderizer. Similarly, dried cucumis powder. So earlier they used the extract, then they used the cucumis powder. It has higher proteolytic activity than fresh pills, and action is more evident on myofibrillar protein than on connective tissue protein. So earlier we have seen the plant origin enzymes are more effective in connective tissue, even in ginger, but here in case of cucumis it is more effective as the powder and on the myofibrillar protein. Due to easy availability and being cheap, this curcumin has a potential to become a better alternative to other proteases, chemicals, etc. used for tenderization. So this cucumis trigonus has a potential to be used as a tenderizer. Now here is the third method, that is the tenderization by infusion of calcium chloride. Use of calcium chloride in pre-rigor meat indicate that by increasing the calcium level or concentration in muscle, the process of aging or conditioning could be accelerated. And measurements suggest that after 1 day of aging, calcium chloride infused bovine muscle was similar in tenderness to control cuts that had been aged for 7 to 14 days. So here we are discussing about a very new method developed through research, that is the use of calcium chloride infusion, and it is injected through the arteries in the cuts, and that can accelerate the process of aging. That is because of the activation of enzymes in the muscle like calcium activated sarcoplasmic factors, which we have discussed. And in a research it has been observed that the calcium chloride for 1 day, it gives an aging equivalent to 7 to 14 days. In continuation about the calcium chloride infusion, for goat meat, after injecting calcium chloride solution within 2 to 3 hours of slaughter, a holding period of 3 days was found necessary for improving tenderness of meat. So in case of goat meat, it was found after 2 to 3 hours the injection is done, and after 3 days only optimum tenderness is obtained. Increased concentration of calcium ion weakens the structures of myofibrillar desmin intermediate filaments. So the action of calcium is on the Z line, where there is desmin protein, a bunch amino acid containing myofibrillar protein, particularly at the Z line, that get weakened, and probably the endomysium and perimysium. It acts also on the connective tissue protein, endomysium and perimysium, and thereby makes the meat more tender. Now here we will see the advantages of calcium chloride infusion. Firstly, no over tenderization of meat. So this won't do any over effect. No requirement of special equipment. Here we don't need any other appliances. Simply we need to inject it after the dressing of the carcass. And easy adaptability of the process at retail level, including household and restaurant level. So this technique can be easily adapted. And lastly, the fortification of calcium level in the meat. So generally meat, particularly the lean meat, is deficient in calcium. So we can increase the level of calcium in this method. Now we are at the fourth method, or the last for this lecture, that is high pressure tenderization. This is again a modern technology, well established and proven through modern research. The application of pressure up to 150 megapascal to muscle and related systems has revealed responses of considerable magnitude and potential usefulness. The post-mortem glycolysis can be controlled to a great extent, and it can be so accelerated that it is virtually completed within few minutes. So this high pressure on the muscle can heavily accelerate the post-mortem changes, and even it can be completed within few minutes. The meat of any desired pH value in the usual post-mortem range can be produced. So in this high pressure technique, we can produce the meat with desired pH in the post-mortem range as we desire. In continuation about high pressure tenderization, the pressure treatment also causes changes in other structure of muscle and results in tenderization. So due to the high pressure, there is a structural change in the muscle and degradation, mainly at the Z line. So Z line is the place where the sarcomeres are joined together. So this Z line degradation causes tenderization through this high pressure treatment. This is due to the release of calcium dependent protease, which we have discussed earlier, that is calcium activated sarcoplasmic factors. So these protease release from the mitochondria and the sarcoplasmic reticulum are affected at high pressure. So due to the high pressure, the calcium activated protease are released, and this affect the tenderization of the meat. Further, in continuation of high pressure tenderization, this is a procedure which has been developed for pressure tenderization of post-rigor muscle. So earlier we have discussed about the tenderization of pre-rigor muscle, or to hasten or to accelerate the post-mortem changes, but there is procedure developed for tenderization of post-rigor muscle also. So in post-rigor muscle, it is the only means by which toughness due to muscle contraction can be eliminated in the post-rigor muscle. So we have seen earlier, due to the heavy contraction of muscle leads to toughness of meat, but such toughness can be removed only through this high pressure technique. But there is only one necessary changes, that is it has to be heated to 60 degrees Celsius for 30 minutes. So to effect the tenderization by high pressure, we need to heat up the meat at 60 degrees Celsius for 30 minutes, then only it will be effective. In further continuation about the high pressure tenderization, this combined pressure and heat treatment result in a substantial decrease in shear force value even in cold shortened muscle. So earlier we have discussed many times, due to the quick chilling, that is before rigor mortis is over, there is a cold shortening which make the meat tough. So such a tough situation can be overcome, or such a tough meat can be made tender by the combined treatment of pressure and heat. That is, I told 60 degrees Celsius for 30 minutes, and after that 150 megapascal pressure treatment. The treated meat has a cooked appearance. So only thing, because it is heated for 60 degrees at 30 minutes, so that after pressure this appearance gets like a cooked meat. And this pressure also influences the action of salt in the swelling of muscle tissues and the dissociation of muscle protein. So due to this pressure, it facilitates the action of salt, causing the swelling of muscle tissues, and also helps in dissociation of protein. So indirectly, this pressure treatment also does some tenderization with the effect of salt. Now we are at the end of this lecture today. So today we have discussed the advanced methods, the modern methods for tenderization of meat. So we have discussed four methods. First one is electrical stimulation. This is very well developed technology and already commercially in use in many modern abattoirs. It is commonly applied as a electrical stimulation just after bleeding or after dressing. There are two aspects, that is high voltage and low voltage. We have discussed in details about it. Then second method, we have discussed about proteolytic enzymes, which can be plant origin or bacterial and fungal origin. Some of the plant origin proteolytic enzymes which are commonly used as tenderizer, like papain from papaya, bromelain from pineapples, and ficin from figs, and recently gingiben found from ginger found to be very effective. So we have discussed all this. Thirdly, we have discussed about infusion of calcium chloride. It is again a relatively modern developed technology. So calcium chloride infusion can make tenderization effect. And thirdly, lastly, we have discussed about the high pressure technology. So high pressure technology helps in accelerating the rigor mortis and early set of rigor mortis or quick post-mortem changes, and it can also be used in case of post-rigor muscle or toughness due to contracted muscle. However, there we need to use the high temperature also. So altogether we have discussed four modern methods for tenderization in a details, and hope it will makes useful learning. Thank you.